Now we are going to solve a problem from June 2020. It is question 23, paper 1, AQA specification. It is a geometry problem. We have plenty of information there. And what you are asked to do, knowing what you are given here, and plus what you know about a quadrilateral, you have to prove that this quadrilateral is not cyclic. You can turn the video off. Try to do yourself and compare your solution with my solution. Here's my solution to this problem. We have a quadrilateral there, and then what we know, the facts that we know about quadrilaterals related to their interior angles is that the sum of those interior angles in any quadrilateral add up to 360. So that's a fact that we know. Now, that we can exactly the value of each of the angle in the quadrilateral. So let's use this. So the sum, we'll use the sum of the angles. So we start with 4x plus 5x plus 30 plus 92 plus x plus 36 is going to give us 260. Now, if you do the calculation, you get 10x. You collect like term here, 10x plus 158 equal to 260. And then we do move 158 on the other side by changing the sign. So we find 10x is 202 degrees. So x, the value of x is equal to 20.2 degrees. Now we can find any of the angles we are not interested in. We can, pick two of them opposite. Why two opposite? Because we know in order to have a cyclic quadrilateral, the sum of any two opposite angles must be 180. Now, if you pick, for instance, angle in A and the one in C and add them up, they must give you 180. If they don't give you 180, that means it's not a cyclic quadrilateral. We can pick the other one, but it's a little bit more to calculate. So we're gonna pick A and C angles, the angle in A and angle in C, and add them up and see what we get. So instead of x, we're going to substitute by its value, 20.2 degrees. So we have 4 times 20.2 degree plus 92, add up to 162.8 degrees. Therefore, since the sum of the opposite angle in this quadrilateral is not 180 degree, the quadrilateral, it is not cyclic quadrilateral. And that is your answer for marks. And pretty easy, pretty quick. And that's it. Very nice geometry problem. Okay.